So chemical reaction, okay, we already learned what is chemical reaction is, okay, involves a rearrangement of what? Rearrangement of electrons in atom to form new substance. So we know that atom has nucleus, there is electron, and there will be valence electron. Those are the electron taking part in chemical reaction. Okay, so this electron may share, lose, or gain to form different type of bonds. So electrons will share, lose, gain to form chemical bonds. But during chemical reaction, we know that if hydrogen combines with the oxygen, it forms water, right? But still, we can see there is the element's identity is not changing. You can bring hydrogen and oxygen back from there. So, the identity of the element is not changing. Or we can say no change in nucleus and identity. Nucleus and identity remains same. Then energy, we learned two type of reactions last unit, XO and N2. They are releasing or absorbing energy, but we have seen chemical reaction, the amount of energy released will be low compared to nuclear reaction. Okay, so in nuclear reaction, the changes will take place inside the nucleus. What changes will take place? There will be change in number of protons and neutrons. Those are the only two fundamental particles present inside the nucleus. As a result, what will happen? One element will change into another. So identity will change. And it will emit particles as energy. We will quote, that's the name for energy is radiation. Okay, energy scale, there is a huge amount of energy released during nuclear reaction. We know that nuclear bombs can destruct the whole nation, whole country, right, within a few seconds. So that much energy it is releasing, very huge amount of energy is releasing in a short span of time. And some of them are continuous. It will emit energy until each particle in that radioactive element is completely converted into a stable isotope. Okay, so radiation is a general term for energy or fundamental particles from radioactive substance. Particles emitted from radioactive substance. Okay, so some atoms are unstable, therefore they will become radioactive. They will emit radiation in terms of particle and convert it into another more stable element, more stable atom. Okay, so we are going to see different type of radiation. The major, very important ones are we are going to discuss now. The first one is called alpha particle. Alpha, using Greek letters, the symbol is like this. Okay, you can write a lowercase a and then I don't know how can you write. Okay, alpha. Second one is beta. Beta particle. You can write a B with the tail. And gamma, it's like a R. Okay, so I'm gonna draw few boxes so that we can include all the properties there. Okay, so alpha particles have positive charge and beta particles are negative, and gamma has no charge, which is neutral. And alpha particles are heavy. It has a mass which is equal to the helium, so we can write the symbol helium 2He4, or you can also write alpha 2He4. Both symbols we can use. Beta particles are lighter, which is like electron, or you can say beta -1 0. Gamma particles has only energy, no material particles present. That's why we learned gamma radiations before in electromagnetic spectrum, because that is only energy, no material particles present there. Okay, so alpha particles are heavy, so their speed will be low. That means they cannot easily penetrate the heavier thing. So I'm going to write low penetrating power. Okay, this one has medium, this one has high penetrating power. Because of low penetrating power, we know that alpha radiations we are used in our smoke detectors. That means we are always, we have smoke detectors our home, school, everywhere, right? So, but our skin or a paper of or thin paper or a cloth, everything can protect you from alpha radiation. So it has very low penetrating power. So it can be blocked by a thin paper. But beta particle little bit more thicker, more high, not thicker, more penetrating power, so it can blocked by a sheet of aluminum foil. If you are covered up in aluminum foil, or if you are wearing protective clothes made of aluminum, you can be safe from beta particle. But gamma, it's very dangerous. It can penetrate your body and kill all your cells. That's why we are using in general chemotherapy or treatment for cancer. So gamma radiations can be blocked only by a thick piece of concrete block, or we have to thick piece of concrete block. But we know that we can't wear that, right? So we can make protective clothes made of lead cloth. Those are the things people those who are working in nuclear power plant, they have to wear protective clothes or mask, everything which has substance which can absorb the radiations. Okay, so you need to know about all of those. So now radioactivity is the spontaneous emission of radiation from where? It is emitting from the nucleus of an atom. Why they are emitting? Because they need to convert in order to attain what? Stability. By emitting radiation. So in order to attain stability. So we are going to see a lot of examples of radioactives. Okay, here carbon 14, you might have heard that in science or in biology, we know that the age of fossils are determined by carbon 14. That is called radiocarbon dating. Okay, if you need to know more about it, we'll discuss in class. Okay, then cobalt is used in cancer therapy. Then plutonium, there are so many are used in cancer therapy. Then nuclear reactors and nuclear weapons, plutonium, uranium 235, all of those are used. We will see that in application. Okay, now we have to complete this table. Let me see. Give me 1 second. Let me cut this. Okay. So we are going to write the table with there are 5 boxes we are seeing, so alpha, beta, gamma, and I'm going to add few more. There are more, but you have to study only 5. Okay, so first we will start with alpha. Particle, we know the symbol is there. Okay, and they are positive, heavy, low energy compared to other ones, high penetrating power. Low penetrating power, high ionization power, actually low penetrating power. So alpha particle emission usually happens in particles greater than atomic number 83, above 83. That means they have a bigger nucleus. So they will emit alpha particle to make them stable. particle symbol alpha, atomic number 2, mass number 4, or you can simply write it is similar to helium but positively charged. Okay, so when a particle emit means it is releasing alpha particle. When an atom emit alpha particle, what will happen? The mass number, it is removing 4 mass number, so mass number decreases by what? 4. Atomic number decreases by 2. Okay, which elements undergo this change? I already said if atomic number greater than 83, they are called heavy elements. They are the one undergoing alpha particles. Okay, let's go down, write an example. Polonium, atomic number 84, mass number 210. Okay, it is emitting an alpha particle, so one alpha particle is removing from there, so you have to subtract. Basically it's basic algebra. 84 minus 2 will be 82, 210 minus 4 will be 206. Now look at the periodic table and identify the element. What is the element with the atomic number 82? Let me open a periodic table. Okay, atomic number 82 will be Pb. So polonium is converted into lead 82204. Okay, now let's go to the second one, which is beta particle. Okay, so energy, they have negative charge. Negative charge, not heavy, and energy is medium, more than alpha particle. Medium heavy, stopped by piece of, yeah. Okay, medium penetrating ability. We already talked about the we can stop it by a piece of paper, right? We already wrote that here. If you already wrote that there, you don't need to write it again. Okay, so this is shown by elements with more neutrons than protons. Usually what happened? More protons. Okay, usually n pi p ratio, we will discuss that later, is higher. Okay, symbol we can write it's electron minus 1 0 or beta particle minus 1 0. Okay, now look at that. So if you are subtracting minus 1 from a number, then atomic number will increases by 1, and you are subtracting 0 from mass number, so there will be what? No change in the mass number. Okay, So this is shown by elements, atoms with a higher N by P ratio. Okay, let's go and write one example. Carbon 14 is a radioactive element which will remove -1 is 0. So 6 minus minus 1 will be 7. 14 minus will be 14, and look at the periodic table, that is nitrogen. Okay. Okay, now let's go to the gamma radiation. Gamma has no charge, no mass, high energy, high penetrating power. Okay. So this is usually happens in high energy atoms. Okay, and I said it is not a material particle, right? And symbol we can say gamma 00. There will be no change in the atomic number, no change in the mass number, so identity will be the same. So it can happen for any element. Okay, so if we are going to write an example, you can write any example, any radioactive high energy 2760. So usually we will write a star symbol or M, because this is very high energy. Okay, it emits gamma particles, that means just energy, and you will get the same element, but the difference, this will have what? Low energy and more stable. Okay, now we will do positron emission. Okay, positrons are positively charged, we can say like that, positively charged electron. Okay, so they have positive charge. It is usually for atoms with a higher number of protons, or if N by P ratio is low. Okay, symbol, we can use the same symbol. It's +1 0, or you can also write E +1 0. So what will happen? Mass number, there will be no change because it is 0, but 1 is emitting, so atomic number decreases by 1, usually by low NP ratio. Okay, write an example. Okay, so positron RB 3781 and emitting a beta particle. It's not beta, it is positron +1. So 37 minus that will become 36. 36 will be krypton and mass number remains same. Okay, so then electron capture, that is the absorption of negative particle. Okay, basically it is the opposite of beta decay, or it is similar to positron. Same change will be similar to this one. Okay, opposite of beta decay. Okay, symbol will be the same of beta particle, but it is absorbing, that is the difference. Okay, so change will be similar to positron emission. Okay, no change. So this will be, it is absorbing a negative particle, so decreases by 1. Loss n by p ratio. Same thing here also, higher number of protons. Same thing. Okay, these two are basically the same except the symbol. Okay, so if you write an example, potassium 1938. Okay, it is absorbing an electron, -1 E0. So what will happen? It will become 18, which is argon, and mass number remains same. Okay, so these are that. Now let's do the practices. Okay, alpha decay, it's very easy. This is called the parent element. This is the particle, and the resulting element is called the daughter element. Okay, here we know that it is 88. You are removing 2, so that will become 86. And 222 minus 4 will be 218. Okay, let's go do this. We need a periodic table. Okay, so we are going to emit alpha particles. So alpha, you can write that first or second, the order doesn't matter. So 103 minus 2 will be 101, and 256 minus 2 will be 252, and you have to look at that, it's mentally VMMD. Okay, so continue and complete all this practice. Look at the periodic table to decide which element is that. Next one, beta decay. It was carbon 6. It is emitting -1. So this is how you are doing. 6 minus -1. So 2 negatives. So that will become 7. So this is the parent, daughter element, and particle. Okay, let's do that. You are removing -1 E0. So -2 -1 just increase by 1. 3, which is lithium, mass number remains 6. Okay, complete that practice. Okay, now positron. We said positron is the same thing with the positive charge. So this is the particle, parent, daughter. Okay, so number will decrease by 1. So let's see, Gonna remove beta positron, which is positive. So 35 minus 1 will be 34 and 75. Then look at the periodic table and find the element, which is selenium. Then complete that, complete all of this. Then electron capture, which is similar to positron. So this is the parent, and this is only time we are writing the particle on the left side, because it is capturing means absorbing, and daughter element. Okay, so did you write on, let me see. Okay, so we are adding an electron to the atom. So 18 plus minus 1 will become 17 and 38. So what is the number with the 17, which is chlorine? Okay, complete the remaining. Okay, so after that there are more practices. Here it says alpha particle, 86 minus 2 will be 84 and 218, and you have to find that element. Look at the periodic table, and this is alpha particle, so that is called alpha decay. Okay, second one, select that, complete those. Okay, next one, I will do one question from G. It says indium. So first you have to write the symbol indium. This is the mass number that goes on the top. Then look at the periodic table, find the atomic number. Then it's undergo positron emission, so that means it is emitting plus 1 E0. So that will become C, cadmium 48 110. Okay, complete the remaining. There are more practices, and here there is a typo there. Just fix that before you do. So all the boxes you convert that into a arrow. Okay, and complete that. Same thing. And this is the activity, we are going to do that in class, and we'll complete that. Then we'll do the nuclear stability next class.